Welcome, and we had to do one word problem to kind of wrap things up. So here we have a multi-force scenario. So we have three forces shown, okay, and some information is given about them. And we want to figure out where the resultant is in component form. And then also we want to know the angle that it makes with F1. So that last part is where that dot product is going to come in because we need to use that to figure out the angle between two vectors, right? All right, let's get started. So first thing, if I want R in component form, R is just what I get when I add up all the forces. So doesn't it make sense to find like F1 in component form and then F2 in component form? Might need a little bit more room. And then F3 in component form. And then just add them all together. And then I have R, okay, in component form. Okay. So I need to find component form. I don't know how far they go to the right and up, or to the left and up, or to the left and down, etc. But what I do know is that remember that the horizontal component is given by, in general, it would be magnitude of a force times cosine of theta, and then the vertical component would be magnitude of a vector times sine of that angle. Okay, so for force 1, I believe it would be magnitude is 32, cosine of, and then here would be the angle for force 1. That's just 90. Oh, okay, that's easy. And then 32 sine of 90. Okay, that isn't too bad. What about force 2? Okay, force 2, magnitude is 24, so 24 cosine and 24 sine. Okay, cosine of what angle? Well, the angle would be, the direction would be here, okay? And it looks to be that theta 2 would be 90 plus 68. So what is that, 158 degrees? Okay, so 158, 158, that goes in there. And then the last vector, vector F3, let's see, magnitude is 15, it'll be cosine, 15 cosine. Now, I could do it multiple ways. I could say that this is your theta 3, or you could say that this is theta 3. It depends if you want to use positive or negative angles, okay? Um, Personally, everything is positive, so I prefer to stay positive. So I would just say theta 3 is equal to 360 degrees minus 40 degrees, so 320, okay? Otherwise, you'd use negative 40. 320, 320. Okay, and these numbers, okay, if you do them out, let's see, so here you'd get 0.32, that's pretty nice. And then here this would be, again, rounding to say 2 decimal places. I got negative 22.25 comma 8.99. And then this last one, again, to 2 decimal places, 11.49, negative 9.64. So when you add them all together, you get negative 10.76 and then comma 31.35. There you go. That's your resultant vector. Okay. Now for me, I just have to visualize where this would be. So let's see, F2 is, I know this kind of goes over here somewhere. I just kind of want to figure out where and how much. So negative 10, this goes negative 22, so it's about halfway. Okay, so that's pretty good. And then vertically, if F2 is about 32, it would be just about as high. So, oh, okay, I actually placed it kind of perfectly. That was a total guess. So here, that would be my resultant vector. Okay, so I didn't need to draw it, but I at least have a general understanding of where it is. It just helps me visualize. And then the second question is, what angle does the resultant make with F1? Okay, so now this is going to be, okay, where's F1? F1's vertical, so I'm looking for this angle here. I'm looking for that angle in there. okay? And that's where the dot product comes into play. Remember that if I look at cosine of theta, the angle between the two vectors, that is equal to the two vectors dot product, f1, over the magnitude of their, or divided by the product of their magnitudes. Okay, f1. Okay, so I know some of this. Okay, I can say, okay, cosine of theta is equal to, I'll have to do the dot product, R1 or R, I don't know. I'll have to calculate that, but F1, it was 32. Okay, so that's nice. Now, if I do the dot product here, okay, dot product is going to be the 10.76. I'll just maybe write it out, negative 10.76 times by the horizontal component, so 0, times by 0, plus 31.35 times 32, okay? And then for the magnitude of r, I get about 33.15 or so, rounding to 2 decimal places, okay? Very close numbers in all of this. And so now, if I do the calculation here, I get that cosine theta is 0.9457-ish, okay, so I'm rounding. And then finally, if I do inverse cosine of that, to solve for the angle, okay, theta is approximately, oh gosh, just shy of 19 degrees, so 18.97-ish degrees would be the angle, okay? And the last thing I want to do is, does this make conceptual sense with my diagram, okay? And yeah, I could see it being 19 degrees or so, okay? So that's always a nice little check to do, but again, make use of that dot product to find the angle between two vectors. And again, make use of that component form just to represent the vectors using their magnitude and direction. So there we go. We are at the end of our study with vectors, and so we get to look forward to some classwork now.